Hello, greetings. Welcome to a nostalgic ramble of mine. I talk about questions from past matric maths papers, and today I'm focusing on question 13 from IEB's November 2023 paper 2. Did I say question 3 or question 13? It's 13. It's 13. Okay, in the diagram below, a house is in the shape of a prism with a triangular shaped roof with one side CN equals 10 meters. Okay, we're given that on the diagram. NCT is 65 degrees, CNT is 69 degrees, T being some point at the base of the root of the tree of the root. The angle of elevation of the top of the tree from C is 43.5 degrees. And again, probably haven't put that information in because you are expected to know what that means. Okay, so I'll just quickly draw that in. So, where my ruler at? So if we are looking up from C to A, the angle that is formed with the ground is 43.5 degrees. Okay. How do I make it go away? Go away. Woo. Ah. Okay, right. So that angle is 43.5. Okay. Right. Okay. And is it possible for the tree to hit the house if it falls? Oh, hectic. Wow. This is so intense. Okay. So, I mean, if a tree falls, if I just think about the tree here, right? And this is its peak, A, right? As the tree falls, I think it will form like a circular trajectory, right? Because the length of the tree remains the same. I'm guessing that this is rooted, like, so it will be pinned to that point, but the rest of it will move, which might also be, faulty thinking. But yeah, this is like worst case scenario. So even if, in actual fact, the tree kind of breaks over there and falls, it will follow this is the worst possible trajectory that it could follow. It can't follow a worse trajectory if it breaks higher than the root, because then it will be a smaller piece that is falling, which will also be interesting in terms of the physics. My science, guys, is, hey, I do not know how I passed, let alone got a distinction for that subject, because 75% of the time I did not know what was going on. Anyway, but yeah, let's just see if my naive physics will get us through. But yes, I think that all we need to worry about is the worst case scenario where this whole tree just tips over, in which case it will make a circular trajectory where it ends up here flat like this, and so what we care about is whether this trajectory at any point touches the house. And so because this is the furthest out the tree will be, or the tip of the tree will be, what we effectively care about is whether at this distance are we touching the house. Because if we are touching the house, or if, worse than that, by the time the tree gets down here, in theory, in our simulation, then that means that, if this tip is further out than the house, then we know that at some point in the tree's journey down, it touched the house. So what I need to know is, what I need to know is whether this, if that is, if I call that distance d, I need to know if d is they've already given us that. If d is what's going on, guys? If d is if d guys if d is shorter than or equal to or larger than the height of the tree, right? And to be more specific, what d is that perpendicular height, right? If you imagine that flat triangle that is being formed by C, N, and T, so if d is smaller than, let's call this length t, or technically if we're using, this would be, if we're using the, I mustn't say technically because really it's not technical at all. I was going to say it would be little c because it's opposite to the c, but in this triangle it's opposite to the n, so so never mind that. Okay, but anyway, if d is smaller than 80, is shorter than 80, then I know that the tree will touch the house before it arrives at the bottom. If d is equal to 80, then hypothetically the tree will fall perfectly, just bump the house, just bump it, but it won't have struggled to get down, So this is the scenario where the tree just lands perfectly at the wall of the house. That's if d is equal to 80. If d is bigger than 80, then that means there's more than enough room for this tree to lie flat. Okay, so we need to figure out those two things. Okay, so I'm just going to draw that out for myself. So the first thing I'm concerned with is C, T, N, that flat triangle. I don't want to draw it that way. I want to draw it with C and N at the bottom, and then T at the top. Okay, and then there's my green line, D. Okay. Right, so I need to figure out how long that is. And what do we know? We know that this is 65. We know that this is 69. So it won't be hard to work out what that is. So that's, and we know that this is 10 meters. Nice. Okay, very nice. And then I also want to figure out the height of the tree. So that'll be, there's a 90 there. This is A, T, and C. We know that the angle of elevation is 43.5. Okay, won't be hard to work out that angle. And that's about it in terms of the numbers we've been given. Okay, so I need to know how long that is, and I need to know how long that is. Okay, how can I find this out? So I'm not sure. Okay, so I mean, I know that if this is x, just this bit over here, then this bit over here will be 10 minus x. This angle is 21 degrees using angle sum. And the neighbor over here is 25 degrees, also using angle sum. And this is 90. And then from there, quang, quang, quang. Oh, I guess I can use simultaneous equations to figure out what D is, right? Because I can set up an equation, a SOHCAHTOA, for both triangles. So I can say so I want an equation connecting this and this, so that'll be tan of 65. So tan of 65 degrees is equal to opposite over adjacent. Okay, and so that is x times tan 65 is equal to D. Okay, so that's my first equation. And then my second equation, if I look at triangle number 2, I've got this angle, I've got that one too. I want an equation connecting these two, that's going to be tan again. So we have tan of 69 degrees is equal to opposite over adjacent. And again, if I times both sides by 10 minus x, then I'm left with this. So this is equation number 2. And I can use this to then figure out what x is. So x times tan 65 is equal to 10 minus x times tan 69. Okay, I'm going to multiply the right hand side out. So that's 10 tan of 69 minus x tan of 69 is equal to that. Then gather all our x terms on one side. So we have that is equal to 10 tan 69. Then we can take out a common factor of x. Right. And then to get x by itself, we can divide both sides by this guy. Okay, and so x is equal to, and I'm just going to keep this in, well, okay, no, let me not do that. It's too bulky to keep rewriting as and when I will be reusing it. So let us not. Okay, so I'm just going to store it instead. Well, I was going to do that anyway. So shift store that in A. Okay, and then this is then just 5,48 blah blah blah. Okay, and I'm just going to make a mental note that I've stored that inside A. Okay, so what we now know is that this x over here is 5,48 blah blah blah, and the other side, the 10 minus x, so 10 minus my answer is 4,51 blah blah blah. Okay, let me just write that down, and I'll store that too. Okay. Well, right. That bracket is too violent. Okay, cool. So we now know that. And we can then use either of them. Don't know if I really needed both of them. We could use either of them to then find what D is, right? So we know that we can use the tan again. So I'm just going to be completely messy and write that over here. Right, so just piggybacking from here, tan, well, not from there actually, from here, right? We know that D will be equal to that number 5,48 dot 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 times tan 65. Okay, so let's work that out. So that is alpha A, okay, times tan 65. So that is 11,76 blah blah blah. Right. Let me store that too. Okay, right, so we now know that D is 11,76 dot dot dot. Okay, right, so now we know how far away horizontally how far away this tree is from the house. So now we need to find the height of the tree, for which, how? Okay, I guess if we can find this length CT, which is also in this triangle, then we can use SOHCAHTOA to find that guy. So in this triangle, how can we find CT? We can use SOHCAHTOA again. So we know how long this is. So we could use cos, adjacent over hypotenuse. If you're really zealous, you could potentially use the sine rule, right? So looking at this whole triangle, sine of 69 over this guy. Okay, we don't have that side. Okay, we'd have to work with a pair whose values we know. So sine of 69 over this guy would be the same as sine of this angle over that guy. That's actually cleaner, honestly. Then I don't have to get these numbers from the calculator. Yeah, so using the sine rule, and because I want to work out a missing side, I'll put the sides on top. So 10 over sine of, okay, we'll have to show how we got these angles, but that's easy enough. Yeah, that's actually making me rethink the plan, honestly. But yes, if you want to go that route, you would say 10 over sine of this angle is equal to this unknown side over sine of this angle. I'm just going to go with cos in my SOHCAHTOA. Adjacent over hypotenuse is equal to cos of 65. So let's do that in another color. So cos of 65 degrees is equal to the 5,48 divided by CT. So CT times cos of 65 is equal to 5,48 dot dot dot. And so therefore CT is equal to 5,48 divided by cos of 65. And if we work this out on our calculator, I think the 5,48 is an A, yes. So divide that by cos of 65, and we have 12,97 wada. I'm going to store that too. Okay, so that is now inside box number D. Okay, so, oh no, I've been doing so well at this. Jeez, man. Kalki, can't let me down. Can't let me down. Okay, so we now know that this is 12,97 dot 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 CT. So this is 12,97 dot dot dot. So then to find AT, we're just going to use tan again. Opposite over adjacent. So, oops. I'm just going to write it here and then transfer it. So, tan of 43.5 degrees is equal to 80 over 12,97 dot dot dot. Okay, and then to work that out, that's easy enough. 12,97 dot 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 times tan of 43.5 is equal to 80. And so 80 is okay, so 80 is going to be 12,31 dot 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 meters. Well, not meters, okay, it is meters, but anyway. So we now know the height of the tree is 12,31 something. Right, and so how does that compare with D? Well, the distance between the tree and the house is 11,76. The height of the tree is 12,31. So if the tree falls, it will definitely touch the house. Well, there's also the interesting thing of, yeah, no, it will. I was going to say maybe like the slant here adds a different dynamic, but yeah, even if it doesn't hit it at the roof, it will definitely hit it somewhere at the wall. An interesting extension to this question that I'm not even entirely sure is solvable is, can you figure out at what point exactly, in a mathematical world, at what point would it hit the house? Would it hit it at the roof? Would it hit it down here? I suspect we might need to know the height of the house in order to determine that, the height of the wall more specifically. The height and the height of the house in general. Anyway, feel free to humor yourself. So, yeah, the conclusion here is the distance of the tree from the house is approximately 11,8 meters. The height of the tree is approximately 12,3 meters. So the tree would hit the house if it fell from its from its bottom, from the down part that isn't the roots. So I'm just going to put this in brackets, okay, which I think is the assumption in the question. Right, let's see if I completely butchered this. So the answer is that it will hit the house. And let's just see what calculations they do. So they use the sine rule to figure out what CT is. And then they look at the triangle ATC Okay, oh, so they're trying to figure out the height of AT. So if they can find CT, then they can use tan in SOHCAHTOA to find AT. Okay, so that's another approach, possibly a shorter approach actually, to finding, didn't have to find D, they just found CT, or at least they haven't had to find D just yet. Okay, so they found the height of the tree to be 12.3 meters. And then they look at this tree that's on the floor in TC. And okay, now they try to find what D is. And for that, they just use SOHCAHTOA, they use sine, because they've got the 65 and they've got CT, which they've worked out using the sine rule. And so they get that. And they find that that is 11.76 and so the tree will hit the house. Okay, so yeah, I do think it was definitely shorter to find CT first using the sine rule. So all they had to do was to find this angle and say, okay, 10 over sine of this angle is the same as this side over sine of that guy. That was a very short way to get CT. And then the height of the tree. And then for the flat triangle, they just used SOHCAHTOA over here, because they have this, they have that angle, and so they can find that using sine of 65. Yeah, but the beauty of different approaches, one of the things I love the most about paper 2 is that there are just so many different ways you can go about solving a question. And I think a question like this, when it comes down to the maths of it isn't very hard. The key thing is being able to identify how to translate something like this. Is the tree going to hit the house? Well, what is it asking mathematically? How can I express the tree hitting the house in mathematical terms? And if that's something that you struggle with, like that translation of, I can see what they're asking me in English, but how do I rewrite this in maths terms? That's something that comes with practice eventually. Some people just see straight away, but some of us just have to practice lots and lots and lots and lots and lots of word problems, pretty much like we did in primary school. So yeah, don't lose heart. By doing more and more of these, you're expanding your brain's tool set. It has more connections that it makes now. When it sees new problems, it has more to draw from. So keep at it, keep trying, and yeah, see you another time for another chat.